Hi, in this video we are going to discuss covalent bond. In the previous video we have discussed ionic bond in which by losing or gaining electrons, atom gain the electronic configuration and stability like noble gases. This is not the only way to gain the stability or electronic configuration like noble gases. Atoms also share their electrons and gain the electronic configuration or stability like noble gases. By sharing electrons, these atoms form the bond which is known as covalent bond. Let's suppose we have two atoms. Each atom share one electrons and after sharing electrons, both bonded atoms have these two electrons. Such bond in which electrons of an atom is the part of both bonded atoms are covalent bond. As represented, electrons are in the hand of both atoms. These are the half-filled atomic orbitals of atoms which overlap, and after overlapping these form covalent bond, which we have discussed in valence bond theory in the previous video. For example, in case of hydrogen atom, this has half-filled s orbitals. These half-filled s orbitals of two atoms overlap, and after overlapping, these have opposite spin and form covalent bond. In case of hydrofluoric acid, this is the half-filled s orbital of hydrogen and half-filled p orbital of fluorine. These half-filled orbitals overlap and form hydrofluoric acid, which have covalent bond. So in this way half-filled atomic orbitals of other atoms overlap and form covalent bond. Here this covalent bond is the sigma bond. After overlapping or forming covalent bond, atoms gain the stability by releasing energy and by gaining electronic configuration like noble gases. Let's suppose we have two hydrogen atoms which are at infinite distance where there is no interaction between them. And when these atoms come close together, attractive as well as repulsive forces operate, and there is a distance where attractive forces dominate. At this distance, these atoms overlap and form covalent bond by releasing energy. So we can say that atoms release the energy and form bond. And by releasing energy in this way, atom gain the stability. As in case of hydrogen, 436 kJ per mole energy release. As well as after overlapping these atoms, gain the electronic configuration like noble gases which are the stable, as the electrons become the part of both bonded atoms. For example, in case of hydrogen, here the electronic configuration is 1s2 for both atoms. As the electronic configuration of helium gas, which is noble gas. Here we can also say that the electrons after overlapping become indistinguishable. And in case of hydrofluoric acid, this is fluorine which gain the electronic configuration like neon, and hydrogen gain the electronic configuration like helium. So in this bonding, atoms complete their valence shell, and as these atoms complete their valence shell like noble gases, We can classify the covalent bond into three types on the basis of number of bonds. The first one is single covalent bond. This is a bond in which each bonding atom share only one electron. For example, in case of hydrogen gas, each hydrogen share only one electron, as each hydrogen has one electron in one s orbital. These atoms share their one electrons and form covalent bond, which we can represent in this way. We can also represent hydrogen atom which has one electron and one proton. These hydrogen atoms share their electrons and form covalent bond in this way. Here these atoms follow the duplet rule and gain two electrons and gain stability. There are many examples where atoms form single covalent bond as fullerene, chlorine molecules, and in case of CH4, NH3 and water molecule, these also form single covalent bond. The second type is the double covalent bond, where each bonding atom share two electrons. For example, oxygen gas has double covalent bond, and when we discuss the electronic configuration of oxygen atom, this has two half-filled atomic orbitals, which are 2py and 2pz. These half-filled atomic orbitals overlap with another oxygen atom and form double covalent bond. These are the half-filled atomic orbitals of two oxygen atoms, which are 2py and 2pz. Each has one electron. Here, two orbitals overlap head-to-head and form sigma bond, and other two overlap side by side and form pi bond. We can also represent the sharing of electrons by oxygen atoms in this way. As each oxygen atom has 6 valence electrons and each oxygen atom shares 2 electrons and having 2 lone pair electrons. In this way, oxygen by sharing 2 electrons form double covalent bond in which one is the sigma and one is the pi bond and complete their valence shell and gain 8 electrons according to octet rule and gain stability. And the third type is the triple covalent bond. This is a type of covalent bond in which each bonding atom share 3 electrons. For example, nitrogen gas has triple covalent bond, and when we discuss the electronic configuration of nitrogen atom, this has 3 half-filled atomic orbitals, which are 3px, 3py and 3pz. These half-filled atomic orbitals of two nitrogen atoms overlap and form triple covalent bond. These are the 3 half-filled atomic orbitals of two nitrogen atoms. These are 3px, 3py and 3pz. Here, two half-filled atomic orbitals overlap head-to-head and form sigma bond, and other two overlap side by side and form 2 pi bonds, which we can represent in this way. And we can also represent the sharing of electrons by two nitrogen atoms in this way, as each nitrogen atom has 5 valence electrons. Each atom shares 3 electrons and have one lone pair electron. In this way, nitrogen gas form triple covalent bond in which one is the sigma and two are the pi bonds, and each nitrogen atoms gain the electronic configuration like noble gases or complete their valence shell according to octet rule. We can also classify the covalent bonds into non-polar covalent bonds and polar covalent bonds on the basis of polarity or the difference of electronegativity of atoms. Non-polar covalent bonds. These can be homoatomic molecules as well as heteroatomic molecules, which are being considered as non-polar molecules. This is considered when the electronegativity difference is less than 0.4. The bonds are non-polar covalent bonds. For example, in homoatomic molecules like Cl2, here the shared electrons are at the center of bonded atoms, as here the electronegativity difference is 0 and these molecules or bonds are being considered as 100% covalent. There are many other examples such as oxygen, hydrogen molecules. These are the non-polar and being considered as 100% covalent. And there are many heteroatomic molecules which have polar covalent bond, but these are still being considered as non-polar molecules such as CH4, BF3 and carbon dioxide. CH4 is symmetrical tetrahedral. Here the bond is slightly polar, but these polar bonds cancel the effect of each other and the net dipole moment is zero. And in case of carbon dioxide, here the bonds are polar, but this molecule is also being considered as non-polar as this has net dipole moment 0. And in BF3, here the bonds are also polar as atoms have different electronegativity, but the resultant dipole is 0. So this molecule is also being considered as non-polar. And the second type is the polar covalent bonds. These are the heteroatomic molecules which have polar covalent bonds. This is being considered when the electronegativity difference is greater than 0.4. The bonds are polar covalent bonds. For example, hydrofluoric acid and bonds in water molecule and in ammonia molecule, these are the polar covalent bonds as the atoms have different electronegativity, and here the electronegativity difference is greater than 0.4. So these bonds or as well as molecules are being considered polar, as these molecules have negative and positive poles. Bonds are polar covalent bonds when the electronegativity difference between atoms is 0.4 to 1.7, and when the electronegativity difference is greater than 1.7, then the bonds are being considered as ionic. But still they have covalent character. Let us discuss with examples how bonds turn from non-polar covalent bond to polar covalent bonds and then ionic bonds as the electronegativity difference increase. In the periods, electronegativity increase as you can see. And when these atoms form bond with fluorine atom, the electronegativity difference decreases from left to right, or electronegativity difference increase between atoms from right to left, as you can see. And as the electronegativity difference increase from right to left, the bond turns from non-polar covalent bond to polar covalent bonds, and then ionic bonds. But here the fluorine is 100% covalent bond, which has zero electronegativity difference. Let us now discuss some properties of covalent compounds. Covalent compounds have low melting as well as boiling points as compared to ionic compounds. This is because unlike ionic compounds which exist in huge crystal, these compounds exist in the form of molecules and have low intermolecular forces. So these molecules or compounds have low melting point as well as boiling points. While on the other hand, there are joint molecules which have covalent bond, have high melting point as well as boiling point like diamond. Non-polar covalent compounds are soluble in non-polar covalent compounds like ether, petrol, benzene. These are soluble in each other. And polar covalent compounds are soluble in polar covalent compounds like water and alcohol are soluble in each other. Covalent compounds mostly exist in the state of gas or liquid like ammonia, water, CH4, etc. Covalent compounds do not give ions in aqueous solution, so they don't conduct electricity. And covalent compounds have directional forces unlike ionic compounds which have non-directional forces. Thanks for watching and please comment if you have any question.